Sayed and Mass Online. Today's topic will be angle between radius vector and tangent. In the previous video, we have seen the polar coordinates and the relationship between the polar coordinates and the Cartesian coordinates. Today, we are going to deal with the angle between the radius vector and tangent. So first, let me draw the figure, and based on that figure, we'll try to derive the relationship between the radius vector and the tangent. Let us consider the coordinate axis. Let this be OX and this represents OY. Let us consider any curve and let us draw a tangent to this given curve. So consider a curve, and for this curve I have drawn a tangent which meets the x-axis, say at the point L. Let me draw the radius vector. So the point of intersection of the tangent and the radius vector, let that be the point P of r comma theta. So this r represents the radius vector. Let theta be the angle between the radius vector OP and the x-axis. Suppose if I consider the angle between this radius vector and this tangent, this is what I need to find out. So let us take this as, say, phi. So we need to find out this angle phi, and let me consider this tangent which is crossing the x-axis at the point L. Let us consider this as angle psi. So this curve which I have taken, so this represents the curve r is equals to f of theta. So this is the representation of the curve in the polar coordinate. R is equals to f of theta. So let me try to explain what I have done in the figure. We have first considered the coordinate axis x and y. Consider the coordinate axis x and y. Then we have drawn, so draw the curve r is equals to f of theta. Then we have drawn the tangent to the given curve. So draw a tangent to the curve, draw the tangent to the curve at the point P of r comma theta, making an angle of psi with x-axis, and we also have the angle between the radius vector and the x-axis, that is angle XOP. So this angle XOP is nothing but theta, and also the angle between the radius vector and the tangent is nothing but phi. So let me consider that angle also. We have angle OPL to be equals to phi. If you try to see from the figure, we have the triangle. From the figure, consider this triangle OPL. So from the figure, try to observe this triangle OPL. So in this triangle OPL, psi represents the exterior angle of the triangle. So if psi is the exterior angle, then you know one of the property of an exterior angle. Exterior angle is always equals to the sum of the opposite interior angles. So from the figure, so using triangle OPL, so we have the exterior angle. So let me write down exterior angle is equals to the sum of opposite interior angles. sum of opposite interior angles. So we know the exterior angle is nothing but psi. Opposite interior angles are nothing but 5 and theta. So let me take that as 5 plus theta. So just using the property we have written in this form. Now if you try to apply tan on both the sides, so take tan on both sides, we'll be getting tan of psi to be equals to, it is tan of 5 plus theta. So this represents tan of A plus B. So you can use the formula of tan of A plus B, which is nothing but tan A plus tan B. So tan phi plus tan theta, tan A plus tan B divided by 1 minus tan A tan B. So which is nothing but 1 minus tan 5 into tan of theta. So we have got tan psi to be equals to tan 5 plus tan theta divided by 1 minus tan 5 into tan of theta. So now let's try to bring about the relationship between the Cartesian coordinate and the polar coordinates. So this relationship we have already proved in the previous video. You can just watch my previous video for the relationship between the Cartesian coordinate and the polar coordinates. So we know this result. We know the value of x is equals to r cos theta, and we know the value of y to be equals to r sine theta. Now if you go back to this figure over here, now this is the tangent that we have. PL is a tangent. So PL is a tangent, and this tangent is making an angle of psi. So this is nothing but, so what will be the slope of this tangent PL? So the slope of this tangent PL will be nothing but tan of psi. So we know that the slope of a tangent is always represented as tan theta. So here we'll try to take the slope of the tangent. So therefore the slope of the tangent PL is nothing but tan of psi. So therefore tan of psi will be equals. So the slope is represented in the form of dy by dx. So that's the basic result that you have already studied. So tan psi will be equals to dy by dx. So this represents the slope of the tangent PL. So what I'll try to do is, because this x and y are in terms of r and theta, so therefore I'll try to divide both the numerator and denominator in terms of, divide both the numerator and denominator by d theta. So divide the numerator and the denominator by d theta. So that will be equals to tan of psi is equals to, we have dy by d theta divided by dx by d theta. So we got dy by d theta in the numerator, and in the denominator we have dx by d theta. But we know the values of y and x which we have over here. So let us just try to plug in these values of x and y over here. So in the numerator you are getting dy by d theta. So can I write this as d by d theta of y? So y value is nothing but r sine theta, whole divided by the denominator you have dx by d theta. So I can write d by d theta of x. So x value is nothing but r cos theta. So let us try to differentiate this one. So if I try to differentiate this with respect to theta over here, so since we are having r and sine theta, so I need to use the product rule over here. If you want to use the product rule, so I'll keep this r as it is. Differentiation of sine theta will be nothing but cos theta, plus keeping sine theta as it is, differentiate r. So differentiation of r will be dr by d theta. So I can write dr by d theta as r dash into sine theta, whole divided by denominator also you're having r cos theta. I have to once again use the product rule over here. So keeping the value of r as it is, differentiate cos theta. So differentiation of cos theta will be minus of sin theta, plus keeping cos theta as it is, differentiate r, you'll be getting r dash cos of theta. So here your value of r dash is nothing but dr by d theta. So instead of writing dr by d theta, I've just written it as r dash. So if you want to get this in terms of tan theta, so what has to be done? So we'll try to observe this relationship of tan psi and this value that you have got over here. So what is the value? If you try to observe over here in the denominator, you are getting 1 minus. So therefore here also, because left hand side is tan psi in this case, left hand side is tan psi in this case. So if the left hand side are equal, you can equate the right hand side value. Therefore I'm checking this 1 here. So can I get 1 in the denominator? Right, I have to get 1 in the denominator over here. So it should be a positive value. 1 is a positive value. So here you are having a positive value, the first value. Next is a negative value. So I need to get this r dash cos theta as 1. So which means I have to divide this by r dash cos theta. So I can't just divide in the denominator. I should divide the same value in the numerator also. So let us try to divide in the numerator as well as in the denominator by r dash cos theta, so that I can get that value 1. Divide the numerator and denominator by r dash cos theta. So if we divide it, I'll be getting the expression to be equals to tan psi is equals to. So each of the term has to be divided by r dash cos theta. So divide the first term by r dash cos theta, plus you have r dash sin theta, divide that term by r dash cos theta. It is whole divided by denominator also. First I'll write the positive value. So you're having r dash cos theta. So I'm writing this expression first, positive value. So r dash cos theta is divided by r dash cos theta. Next you have the negative value. So let me write minus r sin theta. This negative value I'm writing. Minus r sin theta. So that is also divided by r dash cos theta. So if you try to observe, some of the terms will cancel out over here. So let us try to cancel out. So you can see that this r cos theta, r dash cos theta and r dash cos theta will cancel out. Here cos theta and cos theta will cancel out. Here r dash and r dash will cancel out. Try to simplify this expression here. We get the value of tan psi to be equals to. So you're getting r by r dash plus you have sin theta by cos theta will be tan theta. It is whole divided by. So denominator we have 1 minus. You are having r by r dash, I'll write separately, into sin theta by cos theta will be tan theta. So this tan psi value that I have got earlier, I'll take that as equation number 1 so that you can compare this with the present value. So let me take this as equation number 2. So let us try to compare these two equations. Comparing 1 and 2. Comparing equation number 1 and equation number 2. So as you know that left hand side is the same for both the equations. So tan psi and tan psi you have in both the expressions. You can see that you're having tan theta and this tan theta. That value we can see over here also. Tan theta and tan theta, the right hand side. But whereas in the case of this tan phi in the numerator as well as in the denominator. So tan phi and tan phi. So in this place, what you're having is you're having r by r dash and r by r dash, which means tan phi will be r by r dash. So just comparing these two equations, we are getting the value of tan of 5 to be equals to r by r dash. So tan phi, we got the value as r by r dash. So try to observe over here, the value of r dash will be dr by d theta. So let us replace that value. So which will be nothing but it is r by, it is dr by d theta. So r divided by dr by d theta, or I can rewrite that as tan phi to be equals to r as it is. So if we take this dr by d theta in the numerator, it becomes d theta by dr. So got tan phi to be equals to r times of d theta by dr. So this phi represents the angle between the radius vector and tangent. So we got one relationship over here. Angle between the radius vector and tangent. So tan phi will be equals to r times of d theta by dr. I can even write down this relation in terms of cot phi. So which means if I take cot phi, so what is the relationship between tan phi and cot phi? It is nothing but the reciprocal of each other. So tan and cot are reciprocal of each other. So tan phi, if I'm writing that in the form of cot of phi, so I have to take the reciprocal. So its reciprocal on the right hand side will be 1 by r, and reciprocal of d theta by dr will be nothing but dr by d theta. So since tan and cot are reciprocal, so cot is nothing but reciprocal of tan. So I have written reciprocal on the left hand side. So right hand side also I have to write the reciprocal. So r reciprocal is 1 by r, d theta by dr reciprocal will be dr by d theta. So hence I've got one more expression in terms of cot phi. So cot phi will be equals to 1 by r dr by d theta. This relationship gives us the angle between radius vector and tangent. So that's all I have for today. Thank you.